Hey everyone, Chris Mattson here. In this video, I'm going to show you how to make a design table in Solidworks. Let's do it. The purpose of a design table is to allow us to create a single CAD model that is capable of creating multiple parts. These are called configurations. They're variations of the default part that we create. And so what I'm going to do in this video is show you how I created the design table for the shaft example in the book. And what we're going to do is we're going to create a single CAD model that will create all of these shafts. And you can see these shafts have some variations. They clearly vary in length. There's 3 different lengths here. Some have a groove and some don't have a groove. Some have a very large chamfer on the end and some have a small chamfer on the end. And you can see that they have 3 or 4 different materials in here. And so the first thing we do is we look at these shafts, and if we have the shafts, we think about them the way that they are in this book. Or if we're designing a product, we envision kind of the different configurations of the product that we might want. And we create what's called a parametric model. And to create a parametric model, we draw a sketch. And that sketch, we want to pull out the key characteristics of the product, the characteristics that we hope to scale or change or manipulate over the full set of configurations that we're going to have. So this is my basic part. What I'm going to do is parameterize this. And by parameterizing it, I'm going to say, what are the key parameters for me to know about while I'm creating this? There's the length. There is the diameter. There is the chamfer definition, which is usually a length, L2 in this case, times a degree. We're going to go 45 degrees on all of our chamfers. And the chamfer on the left and the chamfer on the right are going to be the same. And then I also have the distance to this groove, which we will call L3. And then I'm thinking now about my CAD strategy. And my CAD strategy is such that I am going to create the groove using a revolve cut. So let me draw out now my groove. It's kind of what I'm looking at in that red circle. I'm going to create this groove using a cut. And I'm going to take that cut and revolve it all the way around the center axis. So as far as dimensions go, there's a few things I need to specify here. I've got to specify this length, which we will call L4. And I need to specify this length, which we will call L5. Now this is my parameterized version of the shaft. And this is the thing I want to model first. It's going to be thought of as the default version. It will be the pattern for everything else that I'm going to create. And because I've parameterized it, I can just put in different values for L, D, and all the L's, and we'll be okay. I'm going to go now to Solidworks, and we're going to go with that. So let's create a new file. We're going to call this dtable example, dtable x. I like to make sure that I'm in the right units, which was mmgs, and then I want to go in and make sure that I have a good material. So I'm going to go in and edit my material. I'm also going to go back to the design guide now, or the design book, and look at what the default material is. PBT general purpose. Okay, PBT I believe is a plastic, so let's go check that out. Is it? Is it? Is it? I don't see it in there. So it's not a plastic. Is it a carbon fiber? Is it a rubber? Why would it be a rubber? Can I search? Yes, let's try that. PBT. Here we go, plastic, PBT, general purpose. That's what I thought it was. I'm going to apply this thing. Close. All right. Now I also know that I'm going to create that groove, as I mentioned a minute ago, with a revolve cut. So I'm going to start my model by getting myself reference geometry, putting an axis that I'm going to use later for my axis of revolution right down that middle. All right, so now I'm going to create my basic default part. And my basic default part, when I look at the guidebook, is going to have a diameter of 10 millimeters. Okay, that's good, fully defined. I'm going to take this shape now and I'm going to push it in just one of these directions and extrude it out there 100 millimeters. 100 millimeters. There we go. Okay, that's great. Then I'm going to add the chamfers on the ends. Chamfer. I'm going to just grab that face, and we'll let that for now be 1 millimeter and 45 degrees. This one over here, 1 millimeter and 45 degrees. We take that. Notice that with the chamfer definition, I can grab the edge or I can grab the face. It's a little faster to just grab the face. And since that was going to give me the same result, that's what I did. Okay. What's the next thing that I need to do in my drawing? I got to go back to my drawing and check it out. Now I got to stick the groove at the end. I prefer to have the groove be offset from this right plane, so that's why I just turned that on to make sure I didn't rotate it around somewhere. Okay, so on this plane, I'm going to sketch something. I'm going to look at this normal to it. Excellent. I'm going to go get my little rectangle tool, and I'm going to choose some value like that. I made sure that this was coincident down here so that it would be connected. And now I have a couple of values that I care about. This distance, which we'll call 4. Okay, this is interesting. That's not the distance that I wanted. And so I'm going to delete that. Delete. And I'm going to come in here and smart dimension from this over to this plane. I had just picked the wrong thing there, and I didn't want to do that. Okay, so we're going to let this be 3, and then we're going to let this height right here be 1.5. One of the things I'm doing, which I think is quite useful with a design table, is I'm choosing some values that are all different from each other. There's 4, there's 3, there's 1.5. The diameter of our entire circle is, what was it, 10, and our length is 100, and our chamfers are 1. Okay, and I'll show you right now why that matters. I just gotta save this sketch and do a quick revolve, and then I'll show you how to do that. Revolve cut with that thing. Excellent. Axis of revolution is that one, and we save that, and excellent. This is basically what we want. We're gonna save this, and now I'm gonna show you why I chose all those different values. We're gonna create the design table, and to create the design table, we're gonna insert this thing down here, tables, and we're going to insert designed table. And on the left, we see that there are some properties of the design table. We're going to just take all the defaults on this. Now what's happening is that Solidworks is opening up Excel in the middle of this, and it's accessing all the parameters that were created or that were used to create all the features on this part. And right now it's showing us all of the dimensions or parameters that are available to us to pull into the design table. I'm going to pull all of them into the design table. And this is my design table as it exists for my part so far. I have one configuration in here. It's called default. I know I have just one configuration because the configurations are listed in the rows. There's only one of them. And the parameter names are listed here in the columns with the parameter values right under their names. And so one of the things I can do here is go back to the guidebook, and I can already tell that I want to create, okay, that was not good. I don't know what's going on with that. I want to create shaft 1, and I'm going to create shaft 1 through 5. Okay, shaft 1, 2, 3, or 5. And I can already see now, remember that my first parameter, this one, D1 at sketch 1, excuse me, this one, D1 at sketch 1 is the diameter of the circle. And I already can know now that I have, looking at figure 1.5 in the guidebook, all those diameters are listed out. So the second diameter on there, or for shaft 1, the diameter is 10 millimeters. So I can do that. The diameter for shaft 2 is 10 millimeters as well. The diameter for shaft 3 is 5 millimeters. Diameter for shaft 4 is 10 millimeters. And the diameter with shaft 5 is 20 millimeters. Okay, that's great. Now I can do the lengths. Okay, I got 100 millimeters on the length. I think 3 of these are 100, so I'm just going to pull these all the way down, find out which ones are not. Shaft 1 is not 100 millimeters. It is 50 millimeters. So what I'm doing is I'm changing the parameter values right here in a table. And then when I'm done executing this table, SolidWorks is going to create these configurations that have these new parameter values in them. Okay, so for shaft 2, I also have 50, 50. And for shaft 3, I have 25. And for the other two, I have 100. Then I have the chamfer dimension. And I don't know the chamfer dimension by looking at this figure 1.5 alone. But when I look up at the top, I can see I have chamfer dimensions. The large chamfer dimension is 2, and the small chamfer dimension is 1. So these are going to be 1 everywhere, except shaft 1 has a large chamfer, which is 2. And they all have the chamfer angle 45. And then this value 4 was the distance from the edge over to the groove beginning. And by the way, this is where those different values mattered. If I had chosen 1 for everything, it would be really hard for me to know in the design table what was what. But since I chose 4, 3, 1.5, I can remember which ones they were. Okay, so 4 is the distance from the edge of the shaft to the groove. And in the design table, we can see those are set to 3 for every one of these shafts. So I'm going to come in here, type 3, and 3, and 3, and 3, and 3, and 3. Okay. Then I have the width of the shaft. Okay, and I'm looking here at the width of the shaft. The width of the shaft is 1.5 on the default. It turns out there is no groove on shaft 1, so not sure what to do with that right now. I'm going to copy these down all the way. I'll show you how to deal with that in a minute. And then all these other grooves are 1 in their width. And then we have the groove depth. Okay, the groove depth is 1, and then it's 0.8 for everything else. I'm looking at and seeing that in the design table that's above the shaft picture. Okay, and then this one's going to be our revolve cut amount that we're doing around the axis, 360 for all of those. After I have parameter values in for all of my configurations, all I have to do is click outside of this. And when I click outside of it, I will now have 5 shaft configurations that were created. And those 5 shafts that are created now can be accessed in this same model. So I'm just going to save this. Then I'm going to go over here to the Configurations Manager. And in the Configurations Manager, I can see that there is now the default plus these 5 other configurations. By the way, these ones are gray because they've not been opened or verified good yet. And so if I go to shaft number 1, I can see my shaft number 1 got smaller. And it now has a check mark by it, which means that SolidWorks opened it and it kind of worked well. I can go to shaft number 4. This one is now longer and there's a check mark. The ones that don't have a check mark just have not been opened yet. So I'm just going to open up all those and check them out. These are very close to the geometry that I need for creating all of the shafts. Going now to the guidebook to look at what's going on here. We have a couple of things that we want to pay attention to. One is we don't have the materials specified in the design table. So let's get it specified in the design table. And so we're going to go over to, so for example, if we go to shaft 1 and we go over to our design tree, we can see that we are PBT general purpose, which is not the right one. So we're going to go back over to our configurations. We're going to edit our design table to include material. And the way that we're going to do that is open this up, right click on it, and edit the table. As we do that, it's gonna find a couple of other parameters that maybe it would want me to bring in here: color, description, part number. I'm not going to bring in any of those. I could, but it doesn't really matter for our particular problem that we're working on. And to make the material specifiable in the design table, we're going to actually just do what it shows in this in the design table in the book. Okay, so we have to recognize that we need to stick a little bit of a code here. The code's going to begin with this $. Okay, $. Whoops, that's not $. $. Library colon material at. Now we need the name of our thing, and the name of our part is this one that's right up here. It's D table X. Okay, D table X is the name of our file and the name of our part. So it needs to know, it needs to connect these together, and that's what the at symbol is going to do here. So that's D table X. All right. If I've spelt this right, library material, okay. If I click out of this, then I can come back into my design table and it will populate that entity. We're going to try that and see if that will work. I think it will work. Edit table. Updating design table. Okay, that didn't want to work, so I'm going to actually just do it the hard way, which is to type this in. I don't think this is case sensitive. PBT general purpose. Okay, we're going to go with that. See what it does. Okay, look, hopefully we weren't getting this error before, because I always want to look at the errors and I didn't notice it if this was what this was saying. Okay, so it's telling us that there's an error. This is great. We get to have a chance to debug our design table. It's telling us right now what our problem is. By the way, if you open up the design table in a separate window in Excel, which can be quite useful sometimes, when you save it and then open it back up, or open up SolidWorks again, it will not tell you what these errors are. And so if you're having trouble, one of the things you can do is make sure you open up the design table in SolidWorks and then close it, and it will come back and tell you some errors. In this case, it's telling us that either this name, SolidWorks Materials PBT General Purpose, is not a valid material, or it is telling us that it does not like this command, $library, blah, blah, blah. And so importantly, it said that it exited the design table without completing the model update. That's really important. Really important to pay attention to that. Okay, so we're going to go back in here. We're going to edit the design table. Design table, blah, blah, blah. Okay, what I'm going to do is choose a different material. Brass. Okay, for some reason it likes the word brass. Okay, I chose brass because it doesn't have any spaces in it. I want to see if that's the problem. Okay, so and it's just telling me right now that the appearance of brass is different than the appearance of PBT general purpose. So I'm good with that. Okay, there's my default version. Now that I have one material working, I think it will pull in all my other materials. So I'm just going to hit save on this, save, come over here into the design table, edit the design table. updating the table. Why did it not want to do that? Okay. Okay, look, this is, I was thinking maybe there would be a drop-down thing here. That's why I came over and clicked on it, and there is. So for now, I guess what I will do is go to my PBT general purpose, which is right there. And interestingly, I don't know if that's going to solve, but we'll try it in a second. Let's pick another one of these, which is, let me just see what else is in here. Let's pick a titanium, but let's pick the correct titanium. Those both say the same exact thing. Okay, and let's jump out of this and see what happens. Okay. Yeah, so this is interesting. That is now giving us another error on this SolidWorks material : brass is invalid material. We're just going to go with this for a second. Okay, and we know that everything else we did in here will not be updated because that error told us that it was not going to be updated. So I'm going to go in here and edit this table. Blah, blah, blah. One of the things that's pretty obvious here is that, okay, look, here's what I was expecting this to do earlier. I will be straightforward with you, which is that I absolutely prefer not to use the drop-down menus, and I'll show you how to turn that off in just a second. Okay, so we're going to save this and see if it knows what the 1060 alloy is, and it will depend on whether it gives us an error, and it did not give us an error, so that's great. That means this is the 1060 alloy because we're on the default version, and if we go over to here, we should see 1060 alloy, which is what we do see. Going back over to the configuration now, this should be PBT general purpose. Whoops. Double clicking on that, that should be PBT general purpose. So I'm going to look over here, and we do have PBT general purpose. So now we're controlling the material in the design table, which is great. Okay, shaft 2 is also, these are also all PBT. I'm going to come in here and edit the feature this time. Instead of editing the table, I'm going to edit the feature. And then enable cell drop-down lists. Boom, I'm going to undo that one. I think that was giving us a little bit of trouble. I'm going to come in here and edit the design table. Now. Okay, and now this is getting us to the way that I was expecting to see it, which was with the words SolidWorks. And I believe that with the drop-down menu, it doesn't try to reference the SolidWorks library that way. It's referencing it through the drop-down menu, which is not how I personally want to control this thing. So I am now going to check the materials that are here. Okay, this PBT general purpose. We're going to put right up into here because that's what that should have been. And then we're going to change this one to brass. And then we're going to change this one to AISI space 1020. And we're going to have this same material underneath it. So bringing that down. Okay, look, this is one thing that Excel does. If you have numbers, it will increment your numbers if you're not careful about it. That's why when we put in shaft 1 over here, it automatically did shaft 1 through 5 for us. This has changed now AISI 1020 to AISI 1021, which is what we don't want to have happen. So we're being thoughtful and careful about how this is working. Okay, and here we want to have our titanium in here. Titanium space TI dash 5 AL, that's like aluminum, right? Dash 2.5 SN. Okay, we'll find out in a minute whether we typed those in right. Okay, and that's come across well. Okay, we're gonna jump out of this and see if this worked. We're going to look over here for some errors. Have no errors on that. So shaft 1 is brass. Shaft 2 is, let's go find out, AISI 1020, which is what we wanted. Shaft 3 should be the same one, so it should look the same, which it does. Though my shaft doesn't, okay, yeah, I was gonna say my shaft doesn't look like this in the guidebook, but this one's not supposed to have the groove on it. We'll find out what's going on with that in a few minutes. Okay, and then this one should be titanium. Let's find out. Titanium, that's right. And then this last one should be titanium, and it is titanium. So we have now successfully controlled the materials with these configurations. Okay, so there's that configuration, there's that configuration, that configuration, that configuration. Now this one should be brass, and then this one should be long and back that way. This chamfer size doesn't look right to me. So I'll have to check that out in a minute. Let's go back to our design table. It's always good to do these kinds of evaluations and to think about what it's looking like. And yeah, look, see, I've messed this up. This should be a 2 up here, and this should be a 1 right there. And that gets us back to proper sizing on that. Okay, that's what my default looks like. Then my shaft 1, yep, looks like that, except it shouldn't have a groove, and so on. All right, so now what we want to do is we want to learn how to control the presence or the non-presence of these grooves. So we're going to go back into our design table, edit our design table, and we're going to use a really important function in design tables, and it is $state at, I'm going to try this one non-case capital because I think it's non-case sensitive. I want to make sure on that. Okay. I am going to change the state of a feature from being suppressed to unsuppressed in the design table. And so what feature do I want to turn off? I want to turn off my revolve cut. So state, $state at cut dash revolve 1. Okay. Now this one I think I can click outside of the table and then come back into the table and it will populate those, I think. Let's find out. I always like to do experiments like this. Design table, blah, blah, blah. Yes, it's come back in as unsuppressed. All of them are unsuppressed. That's what the U stands for. Perfect, because we can now just go in here and change shaft 1 to be capital S. And we can change shaft 3 to capital S. Jump out of this, and we may have finished our design table. Let's check this out. Shaft 1 should have no groove, and it does not. Shaft 2 should have a groove, and it does. Shaft 3 should have no groove, and it does not. Shaft 4 should have a groove, and it does. And shaft 5 should have a groove, and it does. So what I want to do then is, just come up here for a second, turn off these real graphics, because this will allow me to basically filter through these. I'm looking now at figure 5.1. The chamfer looks right, the groove location looks right, the groove depth looks right, the length looks right. Shaft 4 should be the same length, but smaller in diameter, with a groove in the same spot, and the chamfer is the same. Shaft 3 now should be much smaller and have no groove. The next shaft should have a larger diameter and a groove, which it does. The next one should be brass, which it is, and no groove. This next one should be long with a bigger chamfer and actually a bigger groove. And so that is how you get these 5 parts plus the default in one CAD model using the design table. A few things that we learned in here. You have to start with thinking about the parametric version of the product you're trying to create multiple configurations of. If you think about it parametrically, it's fairly straightforward. Number two, you want to make sure that you have created the parametric model as correctly as possible on your first round, meaning before you create the design table, your default version is the product you want, basically. That's helpful. Not necessary, but it's helpful. Okay, and then the third thing is we needed to go in and manage the debugging. And we had to debug a little bit, but we were calm and we listened to the errors and we read the errors. And with that, we got ourselves a working design table that produces all of these shafts, plus as many other shafts as we want to create in a single CAD file. All right, that's it. Thanks. I'll see you in the next video.